this computer. Okay. Okay, so hopefully that is, oh, there we are. Hopefully that's back sharing again. Stick your hand up if you can't see that. Okay, so we're going to talk about passwords today. And I don't have a huge number of slides, a few slides. I'm starting to like that because it gives us plenty of time for chat and discussions afterwards. So first, okay, so this is me, you all know that. So this is the agenda. We're going to start with ancient times, move on to local logins, in other words, logging into your desktop, remote logins, logging into a remote server or your banking system and so on, two-factor and multi-factor logins, various password policies we see, single sign-in, and the big news, which is the whole point of the talk, is talk about passkeys. And then finally, we'll wrap up with some general hints and tips, which is taken from, the various points in today's talk. Now, we've got a couple of videos from IBM slotted in there, which are hopefully be useful to, reiterate some of the points. So I've got two screens here. I can see if anyone puts a hand up. If you want to interrupt me, you can. Otherwise, we'll plow on and have any discussions at the end. So here we go then. So of course, passwords isn't a new idea. They've been around for decades, centuries, I suppose. And it was recorded actually as part of the Roman, rules of engagements, how to use passwords and passphrases. Of course, there wasn't computers in those days, but the idea is really essentially the same, is that you get a password to enter a door, and that is a secret which is shared. And if you want to go into this door, you have to, say the secret word, and you can gain entry. So it's kind of known as a shared secret, if you like. And it's really very similar to the concept we use today. But of course, we don't care about history, we care about today. So we're going to start off with local login. And by that, I mean logging into your desktop, your local machine, with absolutely no networks involved at all. So no networks, just log in to your local device. So what many people don't realize is that your passwords are never stored. What actually happens when you create an account on your local machine, this thing called a digest is calculated from the password, and it's that digest which is stored in the computer. We'll get some examples of that in a minute. And when you log in, the digest is again calculated from the password that you just typed in, and it's actually the two digests that are compared to see if you've got access to the computer or not. So the digests are compared. No passwords are stored or shouldn't be stored. So, if you go to your, bank or, Facebook or something, ask them for your password, they cannot possibly tell you that because they don't store the password. They only store the digest. So when you create an account password, this goes through this function called a hashing function, and it generates a digest. And when you log in again, you type in your password, you go through the same hashing function that generates a new digest, and it's those two digests that are compared. No storing of passwords, which is, kind of quite a key security thing. So if someone breaks into your computer, they cannot steal your password. They can only see your digests, and that is useless to log into the computer. So hashing functions are this magic function that produce digests from strings. And there's loads of hashing functions around. But to use them with passwords, they need to have some particular features. They must be resistant to working out the passwords from the digest. So if you should discover the digest, it should be next to impossible to figure out the password from that. We're talking about billions of years of compute power to try and do that. So in essence, this hash function is a one-way function. You convert a password to a digest, never a digest back to a password. It's one way. Usually they generate, somewhat surprisingly, a fixed length digest. We'll see a couple of examples in a minute to kind of hammer home that thinking. And it's got to be resistant to collisions. So collisions of two passwords generating exactly the same digest must be, the probability of that must be very, very tiny. I mean, it does happen, but it should be next to impossible for it to happen. And it behaves as much as possible as a random function. So in other words, if you have small changes to your password, it ends up with a very different digest. And we can also make use of salt. Now, salt is a random number that again adds a little bit of more randomness into this digest that's being generated. We'll see that in a second. So here's some real digests to, put some color to the words, if you like. So these are the digests here in this table, and this is actually from Linux. And the way Linux stores a digest is, you'll notice there's some dollar signs in here, 3 of them. And the first field, this number 5, is telling us the hashing function being used, which is this guy here. The second field up is the salt. And the final field, this great big long string here, is actually the digest. So this is the representation of the password that you've typed in, which has gone through this hashing function. And some interesting points here. You can see the same password, but with different salts, ends up with very different hashing, very different digests. And if we use the same salt, and you can actually see the salt here, even a small change to the password ends up with a very different digest. So these hashing functions, for them to be useful in password use, has to have these particular features. They need to be close as possible to random, no collisions, and so on. Now, digests are also used elsewhere. It's one part of computer science. And for example, they're very useful to generate checksums for files. So you'll often see things like MD5s of a file, and that's a checksum of a file, but it's done by this hashing function. MD5 is a type of hashing function to produce a digest. Right, okay, no hands up. So hacking, this is a bit I like. So we said before, you can't get a password from the digest, or, it's very, very close to impossible to do so. And also, this digest should be very securely stored on your computer. But here's the but. If the digest is discovered, for example, there's been a data breach or hack on your computer, then it might be possible to figure out your password. And this is the way it works. So if a hacker gets your digest, the way he'll try and reverse engineer or get your password back, he would first take a guess of your password. He would pass it through the hashing function, and that would produce a guessed digest. And then you would compare it with the actual digest that he's extracted from your computer. And if they match, he then knows your password. If they don't match, then they go around the loop taking a guess. And, after a few billion guesses, he might well have figured out your password. So how big a risk is this? Well, there's many tools that do this for you. And there's a well-known tool called John the Ripper, and there's lots of similar named tools. And these are password hacking tools that require the digest of your password. So remember, your digest should be securely stored. But if someone does get hold of it, they can use tools like John the Ripper to try and guess your passwords. So these tools take a big list of likely passwords, billions, starting from QWERTY, password, secret, let me in, all these common passwords, and going through some very unlikely passwords. And what these tools do, they provide various manipulations to the potential passwords. For example, changing a letter O to a numeric O, as we all tend to do. And then it goes through the loops. So it does require dice. And this is a summary table of how long it takes tools like John the Ripper to guess your password, assuming it's got your digest to start with. So you can see the number of characters, and if your password consists of numbers, lower cases, and so on. And you can see some of these very, relatively insecure passwords are pretty much instantly hacked. But once you get to more complex password, then we're talking about billions of years to try and reverse engineer your password. So I thought it was a useful table to illustrate the length and number of characters does influence how secure your password is. Now I've got a couple of things on chat. Do I really need to look at that now? Right, okay, just some thoughts. Okay. So let me carry on then with passwords. So I'll tell you a little story. So I'm trying not to try my best not to name the company, but I used to work for a telco company. Narrows it down a bit. Had about 20,000 people at the time, and I was working in IT. And we went through a process to try and identify how strong people's internal passwords are. And we didn't use John the Ripper, but we used a predecessor of John the Ripper to go through all the digests that we were stored and try to guess the passwords. And we left it running overnight, just overnight. This was a long time ago, so compute powers were very low. The next day, we had a list of passwords guessed from the digest, and we managed to guess all but one of these 20,000 employees' passwords. And this is just from an overnight run. So it guessed mine as well. It wasn't mine that it guessed. So, these things do happen. Which does go to show that protecting your digest is really quite critical. So we're going to move on now to remote login. And by the way, I can see some chat going on. I assume if anyone makes a point, they'll raise their hand either physically or virtually. So, of course, most of us these days don't only log into a desktop, you log into a computer across the network, usually across the other side of the world. And so it's important for us to look at the additional issues we've got with passwords when you're accessing a remote machine. So the first thing to bear in mind is that the network may not be secure. Now, one of the very first tools and protocols to log into a computer across the network was called Telnet. And Telnet is kind of interesting. You still get it, but it's never installed by default anymore. Now, Telnet, I think I've got a little screen. Oh, there it is. Little screenshot. I actually did this on my local machines here. You can Telnet to a particular machine. You get connected and you can log in with your username and password. Pretty simple, very basic way to log into a remote machine. However, Telnet does not encrypt the data going over the network. So what you can do is you can actually use tools such as Wireshark to sniff the network, capture all those individual network packets, reassemble them, and get your password. So of course I tried it. I couldn't resist trying it. So this is Wireshark in action, sniffing my local network when I'm running Telnet to connect from my desktop to a remote computer. And you can see in the background here, we've got Wireshark capturing all the separate packets. And here you can see it was very easy to see the password that I typed in. So this is really ancient history, let's say. These days, when you're logging into a remote machine, you're most likely using your browser. You're most likely using the HTTPS protocol, which is encrypted. Even things like your phones and tablets and so on, all the apps in there will always use encrypted traffic across the network. So this kind of attack is really no longer possible. I thought I'd show it just for interest. So important thing is that when we're doing remote logins, we have to encrypt the traffic. Of course we do. And once they're encrypted, then that hack with Wireshark capturing the packets is just no longer possible. So the first sort of encryption of the network was secure socket layers. These days, that's been standardized into transport layer security, which is really a kind of updated version of secure sockets layers. And HTTPS, we always use HTTPS in our browsers when we're accessing the website these days, is really HTTP over TLS. So they will always be secured. So, when you're surfing the web, you'll get a little padlock at the corner, which will tell you that your traffic is actually encrypted. In other words, it's using HTTPS traffic. And so these, Wireshark capturing packets isn't possible. Now, the modern version of Telnet is SSH, Secure Shell. That's got its own encryption protocol. It doesn't actually use TLS, but it's got exactly the same sort of ideas. All the packets going across the network will be encrypted, so you can't capture your passwords that way. So the principles of these encryption protocols is pretty standard. I'm not going to go into a lot of depth on here because I want to cover other things, but they connect, they agree a protocol, they agree a session key or this shared secret via a key exchange, and then that shared secret is used to encrypt and decrypt all the packets over it. So different users, the same user connecting to multiple sites will have a different session key for each connection. So it's no good trying to capture a packet and trying to replay it. That's not going to work. My machine stopped working here. Oh, key exchange. Right. So I thought it'd be interesting to look at how this key exchange works, because on first thought is how can you exchange a key securely before you've got a secure link? It's sort of like cart before the horse. So I thought this idea was interesting, and I did hear. I don't know if this is true or not. I should have looked it up, I suppose. I did hear that Elizabeth I used this idea to send secure packages to probably Francis Drake down in Plymouth or Plymstone. Anyway, this is the way it works, just to give you a feel for how these kind of security stuff works. So the challenge is here, how do you send something secret to a remote person and without pre-sharing a key to the box? Now if before I send this package, I could have sent a key ahead of that time, and then that would be very easy. But how would you send a secret, a locked box, to someone without pre-sharing a key, but make sure that no one can open the box in the meantime? Well, it's actually remarkably simple. The first thing you do, you get your own key and your own padlock and lock the box. So you hang on to your own key, purple key in this case, and then you send the box over. And that person has a second padlock, blue padlock, and they hang on to their key. And then you send the box back again, and you've got the purple key, so you can unlock your purple key. And of course, the box goes back, and they've got that key, and so can unlock it. I thought that was quite neat anyway. But apparently that was physically done with Elizabeth I on stagecoaches and, big boxes and padlocks and so on. I've not tried to verify if that story is true. So, it is possible to share secrets securely, without any pre-shared keys, if you like. Right, next subject is two-factor or multi-factor. So the problems with passwords is passwords can be...
don't worry. Right. Speaker, it is speaker. Okay, yeah.
I'll mute that. The problem with passwords is they can be stolen, or you write it down and you lose your post-it note or something. So if your password is stolen, then anyone can use it to log into the site. There's no additional security. So along comes this idea of using two-factor authentication or multi-factor. So there's three different types of factors. There's something which is either like a password or a PIN or something like that. There's something you physically have, which might be a hardware key or a one-time password that's been given to you. Or it's something you are, which is like a fingerprint or a face ID, something which physically belongs to you, biometrics. Something something you have, something you are. And these days, if you use banking login or something, you're required to have at least two factors, which might be something you know and something you have, or something you know and something you are. So some examples. A banking ID might require your ID, your username, a password, which is something you know, plus a one-time password sent to you by SMS, which is something you have. Now, a phone app might require, your fingerprints, plus obviously physically the phone, something you've actually got in your hand. And high security bank, I had to do this yesterday. And it does get a bit painful after a while, but might require your ID, your username, plus a password, plus a one-time password via SMS. So you have to physically have your phone, and a one-time password via email. So you have to have access to your email account as well. So this goes way beyond a simple password. You have to have at least two of these different factors to gain access to your account. Now, of course, the downside of all this, it gets very clunky to log in, but of course you can hopefully see the enhanced security it gives you. Another example here. This is, my wife is still working, and when she logs into Office, she has to type in her username, password. She's got a little dongle with a number on it, which keeps changing every 10 seconds, and she has to type in that dongle. So again, that dongle is something that she has in her hand. Now, obviously, it goes without saying, these factors, if you use that, you need to protect them. SIM locks. Now, I'm going to go into that now because this is quite important. So if, like all of us, I suppose, your phone starts to become part of your security regime, particularly when the bank sends you a text message. Now, suddenly your phone is critical. It needs to be protected. Now, one actually reasonably common, it's happened here in Wokingham, where people go to a sports centre, they undress and put their phone in the locker, lock the locker, and go and do their workout or go swimming or whatever. Now, thieves will come in and they'll specifically target those lockers, not to steal anything and not even to steal the phone, but to steal the SIM in the phone. So take the phone out, take the SIM out, throw the phone away, don't care about that. They've got the SIM. They can now put that SIM in their own phone, and now they've got a mechanism to receive these one-time passwords for the bank. So phone up the bank, said, "Oh, I'm sorry, I've lost my card. I can't log in. Send me a one-time password so I can get logged in again." And they plead their case. One-time password will now come to the hacker's phone. That is from the SIM he's just stolen from the locker from the gym. So, the first piece of advice, and we'll cover this later, is lock your SIM. So there's a feature on your phone which controls your SIM locks, and you can type in a PIN number for your SIM, which means that if your SIM is stolen, put into a hacker's phone, they need that PIN to unlock the SIM. Can no longer pick the SIM out of your phone and put it into another one. Obviously, you need decent email security. Also, incidentally, if you get really locked out from all your machines, you should really remember the password for your email, because when you're trying to reconnect to your systems, you've lost your master passwords of things. You get an reset link sent to you via email. Good idea to remember your email password and not rely on it anywhere written down. And of course, if you've got anything physical, like these little dongles with these numbers that change every 10 seconds, you need to physically look after them. Here's some examples. This is my sort of nationwide little dongle. You put your card in, you get a number, and when you log into the bank, you have to type that number in. So it's proven to nationwide you physically got this card with you. And this is my Amex messages coming in. So this is SMS. I'm sure you've all seen these. You get a message, you get a code, and you type in the code to show this is proving that you've got your phone with you. And another way to do it, you can get these things like Authy, which gives you digits, very similar to these hardware dongles, and they change maybe every 60 or 30 seconds. And if you're going to log into the website, you need to open these apps, type in those numbers, and that proves to them you've got access to this Authy app. Okay, no hands up yet, so I'm just going to plow on. So password policies. Bill Bunn, that's a real person's name, at NIST, created password security guidelines. And those guidelines were copied all around the world. All sorts of corporate sites copied them, and corporations and so on. And those guidelines for your password included things like use irregular capitals, use special characters in your password, use at least one numeric, change your password every 90 days, and so on and so forth. And, we've all seen these things, all these policies that come in. However, in 2017, Bill Bunn stood up and made a public apology to the world about these passwords rules. So the new regulations after this public apology, and we've got a video from IBM that describes this in a little bit more detail, is use a password manager. Don't try to remember passwords. Don't write them up. Use a password manager. Length of passwords is more important than complexity. So think about, a passphrase. I like going to the beach at Blackpool sort of phrase, rather than trying to think of some short passwords with upper and lower cases and exclamation marks and so on. Don't change the password frequently. In fact, don't change the password unless you really have to, because changing your password frequently means you have to write it down more often. You're more likely to pick a pattern like password October, password November, and so on, which is obviously less secure. And use multi-factor authentication. And there's some other recommendations with that. So password manager, I think, is our second piece of advice here. I've got hundreds of passwords I need to remember. And so you should really pick a password manager, use that, use long or complex passwords, log them into this little database, make sure you can use it on your desktop, on your phone. And when you open up websites, you can get these password managers to fill in the passwords for you. I'm not going to go too much into password managers. I'm not going to recommend a particular one, but get one, use one. Quite a strong recommendation. So any comments so far? Because we got our first video from IBM coming up next. Yeah. John, do you want to unmute yourself?
Yeah, that should be okay. How secure are the password managers? Presumably they're very strongly encrypt your passwords, or they use some other method, like when you log in locally on your computer.
Yeah, it's a good question. I do touch on this a bit later. When you're choosing a password manager, you should consider this. Now, there's two types of password managers. There's one type where you have control of the database, and there's the other type that some other corporation has control of the database. I would never give my password control of someone else. I'd always want to have a little database where I've got locally, I can share it, I can control it, I can back it up. I'd also go for open source solutions rather than closed source. So there are some password managers that are stored in the cloud by these nice friendly corporations, and you can do some Googling and they've been hacked, which is, the worst of all worlds. So I've got some recommendations at the end, but the key for me is to pick a password manager where the database of passwords you manage.
Right, thank you.
Paul.
Hi, can you hear me?
Yeah.
Yeah. Hi. I was just wondering about the the salts. Do they tend to be random per user and per website, or just per website? Because I'm not sure how a lot of websites are doing it at the server end.
Yeah, so each server you're logging into will have a list of usernames. And typically when you register, it will pick a random salt just for you.
Yeah,
And
right.
when
So that's then salted against your username, and it's got to match the username against the hash.
when you log in and type your password again, your username is looked up and your original salt is located. That's fed into the hash function to create your digest to verify you.
Right. Okay. So and the hashing is taking place as well at my end in the browser, isn't it? So you've got to trust your browser.
Um, it depends. Very often that will be done on the server and you log in over a secure connection.
So that would imply then that at some point the characters of my password are going over the net, although protected by HTTPS, they're actually going over as individual characters.
Correct.
Ah, okay. So at some point, if the server's been trashed or hacked, it could be recording my actual password. And
Yep.
following on from that, that some of these sites force you to use certain password patterns, like so many characters, so many numbers, so many punctuations, etc., which again implies that they're probably reading it, discarding it, and incrementing a counter each time to make sure you've met their rules.
Yes, so those password validations are usually run in the browser because it's quite easy for your browser to check for it. Now, I said yes to your question earlier that your password could be going over the network. It may not be. It could be hashed in the browser and your digest sent over. But certainly, I know of cases where the password is transmitted over the secure link, and so your unencrypted password does arrive at the website, even though they never store that and convert it to a digest as soon as possible. I
Yeah,
mean,
okay, thanks. That's clarified something because I've always used a strong password for things like banking and things,
Mhm.
and via a password manager, but a weak password for things like club websites if I just want to get the club newsletter or whatever and establish I'm a member. Because if it hasn't been done properly and people reuse passwords, which they do, particularly if they're not using a password manager, then of course there's there's a really big risk there. The only other thing I would say is that if you're going to use a public Wi-Fi, for instance, or an untrusted overseas network for your phone, I would really recommend use of a VPN to stop any network sniffers getting any knowledge at all.
We actually had a talk on that, including a video. And you have to remember that, the VPN obviously encrypts all your traffic, but so does HTTPS. So if you're using HTTPS from your browser in a cafe somewhere, they're not going to be able to get your password. Your VPN is just encrypting an encrypted link. It's doing it twice. It'll slow you down a bit. That's probably the only impact of using a VPN.
Well, yeah, it also hides where you're going and what you're trying to do as well.
Yeah, so
any traffic that takes place right at the start of establishing a connection.
Yeah, that's
you can still do man in the middle, can't you, with SSL and HTTPS if you do a relay forward attack that way, and effectively you've got 2 SSL or HTTPS sessions taking place if you can get in on the network.
And that's hard to do because it means the man in the middle would have to have a key generated by a certificate authority. If that happens, and I've tried it actually, your browser will give a warning, and actually very strongly worded warning saying there's probably a man in the middle attack. So that's detectable by your browser, that particular case. But you're right.
Thanks, Peter. That answers my questions. Thank you.
Yeah, but you're right in saying that a VPN is useful for hiding your IP address. If you wanted to watch, Netflix in a different country, then VPN gives you, an IP address which is outside of your country.
Yeah, for some reason the BBC seem to detect I'm using a VPN even when I'm coming out at a British point of presence. So, so they force you to turn it off. But certainly, I mean, another reason for using a VPN actually is to cut down a lot of the marketing stuff and things like that. And that's principally why I use one. But you have to use a trusted VPN because your VPN sees all your traffic. So, in that sense, it's no different to your telco or your ISP.
Indeed. Yep. Yeah, it sounds like you missed our talk on that. Jeff.
Hi, Peter. Thanks for your talk. It's very interesting.
We're not finished yet.
Yeah, right. A simple question. Going back to your nationwide dongle, I think you call it, where you put your card in, and obviously it generates an 8-digit code that you put into the banking. So are you telling me that obviously that little machine is randomly selecting 8 digits, and there's something in the bank that at the same time is randomly selecting the same 8 digits?
That's essentially the way that works. The nationwide is a little bit non-standard. The nationwide dongle is there to prove to the bank that you physically got your card. So it reads your card and it generates a number which is based on your card. You type that number in, and that's enough to prove that you physically got your card in your hand. The same as if you're going into a branch. The things like Authy that I showed you with a 6-digit number, they change every 30 seconds. And these are set when you first set them up, you go through an authentication process, and it does mean, yes, the server knows, but simply by the time of day, that what's being displayed on those numbers can verify that those 6 numbers should be displayed on that particular piece of software right this minute.
Right. Okay. Great. Thank you. I was just thinking, all the hundreds, millions of those nationwide machines that are out there, and Barclays Bank do this similar sort of thing as well. That's an awful lot of random numbers being generated by those banks, etc.
Yep.
Yeah. Wow. Thank you.
Tommy.
Yes, just a simple comment. I tried the same dongle in 2 different banks, and they worked. And one was in the UK, the other one was far away abroad. Yeah,
but as I say, the purpose of this nationwide one is not to prove that you've got the dongle, but prove you got the card in front of you.
Both required my cash card.
Yeah.
So I had to prove that, yes, I have the cash card, the debit card, and it worked. in both cases.
Yes. Well, that's reasonable because it's just proven that you've got the card. Okay. No other hands up, so I'll proceed to our first video.
I hate to tell you this, but you're probably doing passwords wrong. At least that's what the National Institute of Standards says in the document they produced a few years ago with password guidance. It basically says what we've been doing as an organization with password strength policies is making security worse, not better. So the old rules, let's take a look at those. It was that there was a formula that you needed to follow. Mixture of upper and lowercase characters, numbers, special characters, things like that. And what that does in combination with an expiration date is make it so that users end up with passwords they can't remember. And if they can't remember them, then they have to write them down. And if we make them change them a lot, then they've really got to write them down. So instead of the old rules of a formula and expiration, in fact, the new guidance is that we should look at length. Length is strength when it comes to passwords. The longer your password, the harder it's going to be to crack. And if you choose something like a passphrase, something that is something you will remember, maybe even a sentence. If you came up with Mary had a little lamb, you can remember that very easily. And don't choose that one because everyone else will guess it. But some phrase like that is long and hard to crack and easy to remember. And don't change your password. The new rules say have them last indefinitely. Unless there's a particular reason to change a password, leave it in place because changing them constantly is causing people to choose bad passwords and write them down. Old rules also said provide hints. In case you can't remember your password, right there on the login screen, it might say something like, okay, here's a question to help you remember what your password is. The new rules say, nope, no hints. Because think about it this way, why would we give a hint to an unauthenticated user? We don't know if it's you or not. If you're the bad guy, I don't want to be making it easier for you to guess what my password is. And the old rules all relied on secret questions to reset. If I've forgotten my password and need to come up with a new one, then there's a set of questions that I'll ask you that presumably only you would know the answer to. The new rules say, no, go out of band for that kind of connection, for that kind of reset. In other words, make a phone call, make a text message, use some other form of communication in order to verify that the user is who they claim to be, because the secret questions turn out not to be all that secret. In fact, most of those answers that relate to your favorite this or that, or your high school mascot, can all be found on social media. So old rules lead to more insecure passwords. New rules lead us to a better user experience and better security. Thanks for watching. Please remember to like this.
Right. Moving on to our next little subject, single sign-ins. Now, this is something that I'm sure you've all seen, but maybe not recognized it as such. So the idea here is you authenticate to a trusted server to gain access to a second server. Okay, so it avoids having yet another password to a website. You've just got one password to log into this trusted server. And there's no shared secret. But this can also include access to resources such as, email and files and such like. Now, it works quite nicely because we'll go through an example in a minute that will clarify things. But after you've authenticated to this trusted server, a token is granted, which you can then later withdraw, or it can be expired. So you've got control over how long you log into this second server. And this single sign-in, well, one form of it is called open authorization, or OAuth 2 is like the technical term for it. So, for example, to log into booking.com, you can authenticate via Google. And it's also known by other names such as third-party apps or connections, sort of a bit more of a marketing names. There's a second form of the single sign-in, which is starting to grow in strength because it's going to be used to have this shared pension platform from the government. So it's open banking. So it means you can grant financial aggregators tools to have limited access to your bank's details, perhaps just a balance or your pension fund. And so the government, for example, is going to launch this aggregator for your pensions. So you'll be able to log into a government website and see the total sum of all your pensions. And this is what it looks like, and I'm sure you're very familiar with this. So here we're trying to log into booking.com, and we can either use an email address which you've previously registered with booking.com, or you can authenticate via Facebook, Google, or Apple. So if you authenticate by Google, you click on there, you type in your Google username and password, or maybe you're already logged in, and then that gives you access to booking.com. So it means that booking.com don't have any kind of password or even digest of you. It just knows that you've been given granted access to booking.com via Google. Now, because you've logged in via Google, you can now use the Google tools to manage that login. So, you go into various sites, and you can you can delete your connection with booking.com. If you've fallen out of love with booking.com, you can go and delete that, and then booking.com then have got no idea who you are again. So it's a nice idea. So it does mean you can choose to trust Google or Facebook or Apple or other sites as well, and then don't bother creating passwords for these other sites. Everything via this single sign-on server. So the way it works is, and I'm sticking with this example with booking.com. So on your desktop, you're going to go to booking.com to log in, that screen I showed earlier. And you click on the little Google or Facebook or Apple icon, and that redirects you to the Google server where you log into Google. And then what happens behind the scenes, Google generates a token or authorization code and sends it to booking.com. So there's a relationship here between your authentication server and the site you're trying to log into, and it generates this token. And that's fed back, that's authorized to Google. Now booking.com knows your token, and you can go in and use the facilities on booking.com via this token. And then later on, if you choose to fall out of love with booking.com, you can go to Google and you can delete that token so that you can no longer log into booking.com, and they no longer know anything really about you. So in this case, we're not generating a username or password with booking.com. We're doing it all via a single sign-on server. So this does mean, of course, that you need to trust your authentication server. And that depends on your risk levels. Personally, I wouldn't trust Facebook with anything. So I'd never, ever use single sign-on via Facebook. But, personally, I've worked with Google before, so I kind of trust where they're coming from. So I'm happy to use Google. Other people hate Google and will refuse to use it, which I understand as well. So you do need to trust your authentication server. And, a lot of people love Apple, and so we'll stick to the Apple way of doing things. Log in once via Apple, and then suddenly they got access to many websites just with a single login. Hopefully that's getting some clarity there. So now here's the point of the whole talk. This is the thing I wanted to introduce to everyone because I've not seen a lot of talk about it. And there's this thing called passkey. So this is a relatively new way for users to sign on to websites with no passwords involved whatsoever. So we had the question earlier, how can we get rid of passwords, I think from Pete, and passkey is a way to do this. So it's similar to, the user interaction is similar to unlocking your phone, either Face ID or, fingerprints. You just press your fingerprint and your phone is unlocked. This is similar. So you go to a website, you put your fingerprint on and you're instantly logged into the website. So it's from a user experience point of view, it's very easy, but yet it's secure. So you can gain access to, let's stick with the same example, booking.com, just with your fingerprint. Oops, something happened there. Sorry about that. I think I managed to click on stop sharing by mistake. Let me get back to that. Hopefully we're back again. Hey, sorry about that. I hit the wrong button. So passkey, so it's similar to unlocking a phone. You can use a fingerprint or a face scan or, one of these little patterns or even a PIN number to gain access to a remote website. So a few things on the terminology. Passkey is like the marketing name, if you like. WebAuthn is the name of the API, so developers will know it by this name. But there's a consortium that manages these standards, and it's called FIDO, Fast Identity Online. And this is an organization really that manages all the protocols associated with passkey. So you'll also see FIDO being mentioned on a website. Do you want to log in with passkey? Do you want to log in with FIDO? So there's a registration phase, and that means the key to the website is stored in your browser. Now, I've got a better video to describe this again from IBM shortly. But the thing is, it's browser-based security. So once you've registered, you've got this key stored in your browser. When you log into that website again, you just need to unlock that key with, your fingerprint or a PIN or a face scan, and then your browser can go logged in straight to the website. So it's a bit like OAuth 2, but no shared secret as such. And this is what it looks like. Now I'm a bit lucky. I'm running on my MacBook here, and it does have a fingerprint sensor on it. I know it's unusual for a notebook. So I can use passkey to log in to Google and other sites just because I've got, a fingerprint scanner on my desktop. So you go to a passkey website, you'll get this pop up. Do you want to use it? Calls it Touch ID. But I do mention passkey here. And then you can do a fingerprint scan, and then you're logged in straight to the website without typing any passwords. And that's the whole point of passkeys. So what I'd like to do is to run a second video by IBM, all about passkeys. And then we'll start wrapping up, and obviously we'll open up for further discussions.
You know what I hate? I mean, really hate? Passwords. There's too many of them. They're hard to keep up with. I'm losing them all the time. I'm going to go out on a limb, probably not very far, and suggest that you probably don't like them either. Well, what if I told you there was a way that we could get rid of these things without compromising security? In fact, a way that allows us to improve usability of the system while also improving security, which is something that's hard to do, both of these at the same time. That would be interesting, right? What's the name of the technology that lets us do this? Well, it's called Fast Identity Online, or FIDO for short. No, not that FIDO, although he really hates passwords too. And what does FIDO do? Well, it's a protocol that allows us to get rid of passwords by replacing them with something we call passkeys. And it's not something brand new, even though you may not have heard of it before. It's been around since 2013, the FIDO Alliance, this industry consortium that put together the standard. And in fact, there are more than 250 organizations that are using the FIDO standard and are part of this alliance. And now what's new is there's a newer version of this called FIDO 2 which incorporates two new elements that are particularly important. Hardware-based authentication. So now I can use biometrics or hardware-based tokens. Think a phone that is something I have, and then using my face to unlock the phone, something that I am, that we can do that sort of thing. And we have support now for web browsers, which now extends the use cases and the possibility of all the different places where we can use FIDO. Okay, so how does all this magic work? Well, let's start with a quick review of cryptography. Some of these concepts are going to be important in understanding how this could be possible. First of all, we have two main different classes of cryptographic algorithms. We have symmetric and we have asymmetric. With the symmetric algorithm, I have a single key, a symmetric key, and that key is used to encrypt as well as decrypt. So if I encrypt a message, I use this key. I want to decrypt it, I use the very same key. So that means both sides have to have that key and know what it is. That's how that works. Symmetric because it's the same key on both sides. However, when we go over here to asymmetric cryptography, it's a different situation. We have two mathematically related keys that share this unique property, that whatever I encrypt with one can only, in fact, be decrypted with the other, and vice versa. If I encrypt with this, then I can decrypt only with that. So these are related, but they are not equal. Now, we're going to use that special quality in order to do the magic that we're going to do with these passkeys. For instance, and in fact, what we do, we refer to these, one of them as a public key and the other as a private key. And so let's take an example of how we would use these. So here is our user going to log into this website. First of all, they need to register. How does the registration flow work? Well, it's sort of like this. User is going to send some registration information over to the web server. And as they're doing that, in this process of registration, the user on their device is going to generate both a public key and a private key. So an example of each of these. The private key is going to stay on this device and never leave it. And we're going to lock it down with some sort of biometric or other strong authentication capability. So the private key stays on the device. The public key, however, we share with the web server. The web server takes that public key and puts it in a database and associates it with this user. Now that's the registration piece. Now, what do we do next is, let's say this user, we do that one time. Now the user wants to log into the system. So now what we need to be able to do is authenticate. The authentication flow is going to work like this. So the user is going to send information to the web server. For instance, they're going to put in their username and say, hey, this is me. I'd like to log in. The web server says, oh yeah, I remember you because you registered with me before. I'm going to pull in your public key because you shared that with me. And by the way, there's never a problem with sharing a public key. That's why we call it a public key. Only problem is if you share a private key. So we take the public key that's been shared in advance, and we're going to then calculate a challenge of some sort. So that is a specially designed message that's going to have some information, probably a timestamp and other things like that that are unique. And we're going to encrypt it with that user's public key. And remember, if it's been encrypted with the user's public key, only they can decrypt it because they're the only ones that have the private key and they've locked it down on their device. This is where we start getting the real security capabilities. He sends the challenge over to the user. The user decrypts it with their private key. And then if they're able to read it, they're able to see what's the challenge message, and they can then respond to the web server, encrypting the response that proves that they have read the challenge message, and they will encrypt that again with their private key and send that back to the web server. The web server then is going to take that, and we do the final step. That is verification. Verification means the web server now is going to take this response message that we got. We're going to decrypt it with the public key, and we're going to compare it and see if it works. If the challenge we sent matches the message we got back, then we can prove that this user is in fact who they claim to be, and we will allow them to log in. Notice what was not ever happening in this case. There were no passwords. At no time did you see a password come out of my hands. In this case, we stored the private key on the device always. We keep the public key, share it with the web server. The web server associates that with the user, and then we just do a series of challenges. So for this user, all they have to do in order, when this challenge comes across, unlock their device, indicate maybe on the device that this is the website I want to log into, approve that, and the rest of it happens automatically. Okay, let's review really quickly what we've talked about. So with FIDO, we keep the private key on the device itself, and we guard it with multi-factor authentication. So that way, nobody else can see it. It remains private, and therefore only that user can decrypt and encrypt with that key. The public key, however, is shared. That's why we call it public. We share that with the service provider, with the website, or what have you. And that's okay because of the mathematical relationship between these two. Having one doesn't allow you to figure out what the other is, which is nice. Now, one of the things that's really nice about this, not only do I get to get rid of passwords, but there's some downstream effects that occur from that. For instance, it resists phishing attacks. So the phishing issue often occurs because someone is able to coax you out of your credentials. You click on a website and log into a bogus website, and you give the attacker your login, your user ID and password. If there's no password, in other words, only pass keys in the form of these challenges and crypto mechanisms, then there really is no password for the phisher to gather in the first place. So we resist a lot of those phishing attacks. That's a nice side effect. Another thing is it resists replay attacks. So a replay attack is one where a user or an attacker might sit on a network and see the information that you're sending. When you go to send your password over the network, maybe it's in an encrypted form in the form of a hash, and they take that hash and they don't even have to know what it says. They just need a copy of it, and then they replay it and send it to the web server as if they were you. In this case, we've got a system of challenges. They wouldn't know what to send because they'd have to see what was coming in the first place. So we resist replay attacks. And finally, it gets rid of passwords for us. Those things that we hate, the things that are hard to keep up with, the things that can be forgotten, the things that people write down, the things that people are not very creative at coming up with in the first place. In this kind of a situation, there's no passwords involved. The pass keys are all based upon information with these public and private keys, which are automatically generated, and they're complex and strong, and the user doesn't have to keep up with it. And you know what? This has been around for a while. In fact, IBM has been supporting FIDO2 since 2018. And there's a lot of other vendors that are jumping on board as well, as I told you to begin with. So this is something that I believe is going to be the future of logins and authentication. And the beautiful thing is the future is free of passwords.
Okay, good. I'm glad I didn't have to explain that, get IBM to do my job. So we're wrapping up now.
Peter,
Yeah.
it's Neil. Can I just ask you on that? Can you just put up that very last bit of that film, or is it buggeration to do that? It's just
You know,
it right at the end. On that diagram on the right,
automatically generated.
Yeah, on this.
Yeah.
Can I just, I mean, I don't know anything like enough about computers, but fundamentally, if you've got a public key and you've got a username, both of which are probably not that difficult to be able to establish what hacking do, why can't you issue a challenge? Because if you know an email and you know a username, or you know some sort of connection back, why is it going to be so difficult to create a challenge that would go to the user? I mean, that's the bit I don't quite see.
The key here is that when you do this registration, the registration process means generating a private key and a public key, these matched pairs of two keys that's got this.
Yeah.
And
so
you,
the initial
you are responsible for the private key. You keep that locally, you keep that secure.
Yeah.
And you share your public key. And it's
Right,
a private key that really, the matching of those two keys that gives you the protection.
right. So the challenge then has to actually recognize within whatever it's doing, it is having some recognition of the private key that's been generated.
Yeah, so these
Okay, that's fine. Okay, yeah,
these
that's fine.
messages here are actually encrypted with either the private key or public key. So when you get a challenge back, you can only view that challenge if you've got the private key and can decrypt that message.
Yeah. Okay. No, that's fine. Yeah. It's just on the diagram you drew that wasn't absolutely clear. So okay, right.
You know what I hate?
Yeah.
Oh,
Great. Thanks.
yeah. Okay, so John.
I'm confused, Peter. You within this concept of passkeys, for instance, you talked about a fingerprint, and I can see quite how a fingerprint contains a very large amount of information, which makes fingerprints by and large unique-ish. But I don't have a fingerprint anything on my computer at home. I put in a PIN number, and the PIN is 4 digits long.
Yes, so let
There
me
are 9,000 and some. I assume they don't use the obvious ones. So there are only 10,000 of those, let's say. How in any sense is that the use of that PIN anything like secure as a fingerprint?
Yeah, so the way it works is, as we just talked about there, is the key for passkeys is that you hold your private key locally and the public key is on the server that you give away to the server. And it's this matching of the private key and public key that gives you the security. And your private key is stored in your browser. And so when you log into the website, that private key is used to decrypt and encrypt stuff, gives you a password. But of course, if someone walks up to your browser, they can instantly log into that website on your behalf. So the local fingerprint on the local PIN or the local Face ID or whatever desktop security you want, that is simply locking your browser to stop it giving away the private key as you log in. So it's a bit like a screen lock. It's more like a screen lock. The PIN, the Face ID, the squiggling on the screen isn't actually used for the protocol for the encryption. It's just unlocking your browser. So think of that as more like a screen lock rather than part of the encryption protocol itself.
And that applies to, as I said, I have a PIN number to log into Windows at the start of the day. Yep. Is that doing exactly the same thing?
Yes, so you could have passkeys that unlocks your desktop with your Windows login, and then you just go with your browser to booking.com and you're logged in straight away because you've logged into Windows and that's unlocked your private key, then you can go straight into booking.com.
Conceptually, it doesn't feel anything like as secure as a fingerprint. But
yeah, your fingerprint's just simply unlocking access to your private key. And it's up to you really to choose a local security mechanism to protect your private key. Hopefully that makes sense. Paul.
Yeah, just one thing. One thing I'm a bit wary of. It's all right if you're using the same device every time to do single sign-on and passkeys, that kind of thing. But if you end up traveling or something and you need to use a hotel computer or a library computer to reconfirm your flights or whatever, and you can't get onto the BA website because it's all on your box at home, do these websites normally offer a backup way of getting in so you can use a password you can write down and take with you or remember, or are you stuck to needing the device you actually registered on in the first place?
No, if I did show a screenshot of a fingerprint and passkey running, and I don't know if you remember, underneath there it says use an alternative method to log in. So the sites will always drop back to a username and password if passkey isn't working for whatever. But these private keys, you can make sure they're available on all your devices. For example, by storing your passkey in your password manager.
Yeah, I mean, that works quite well with Apple and their keychain, but it's when you end up on a Windows box that you're then into a slightly more nightmarish scenario of
Yeah.
needing to get access to something while you're away from home. You haven't got everything with you. One thing that I also would say, though, you have to be really careful that private key is well protected. And of course, anybody who's hacked into your system, it's game over at that stage anyway, because they can see everything you type and everything you can see. But that's, you know, that's further down the line. If someone's got that level of access to your box, then there's not a lot you can do except rebuild the box and things at that point. The other comment I would make, and I thought that was quite a good presentation, that both yours and what I've just seen, is you have to make sure that the public key, although they're public, you have to make sure it's associated with you. And that there's a good strong binding between that and the person who's the person who's paying, and what the website sees, because otherwise, you have a problem. One thing that does concern me nowadays is that how good are certification authorities with their business due diligence to make sure that somebody is who they say they are when they're setting up a website and getting those web credentials signed.
Yeah, good points. Don't have any particular response to that other than, yes, I agree. Okay, so I'll just sum up with a summary slide, if you like, getting back to practical hints and tips about passwords. So it seems to me and many people in the industry that passkeys are the way to go. They avoid an awful lot of problems with the passwords, and yet remain easy to use. Certainly much easier to use than the multi-factor authentication. If you use OAuth 2, the single sign-in, so you log into Google and get access to booking.com, that's good as well. But you've got to make sure you trust this authentication server and also what resources are shared. Because if you use google.com, you set it up, very often you're going to share maybe your email or your Google Drive or your calendar with this third-party website. And that might be good. That may be exactly why you're using OAuth 2, but it might be bad as well. So it's always good to every so often go into your authentication server, just review the list of people that you've given access to, and delete old ones or whatever you need to do. Make password complex and unique, but better to consider a long phrase, as we know now. And to state the obvious, don't use your pet's name or your wife's maiden name or anything that may be shared on social network, because that will be used to reduce this list of passwords that hackers are going to use to try and guess what your password is. Obviously, don't write down. Use a password manager. Even passkey is coming out and it's been available for a long time. Not a huge number of websites support it. So passwords are still going to be around for the foreseeable future, which means we need a decent password manager. And I personally would recommend that you choose a password manager that stores your database of usernames and passwords in a way that you personally control. So avoid these websites that manage everything for you. Who knows what they're doing with that, and they have been hacked. So I use KeePass. I'm not particularly recommending it or not recommending it, other than say it's open source and it's really about a design of the database to store the usernames and passwords. And so you get different versions of the KeePass application to work on your desktop, your phone, or wherever, all with the same database. So it works quite well for me. KeePass, though, doesn't quite yet support storing the private keys for passkey. So we're waiting for the next version to come out, and then that will also be storing my passkeys as well. And there's some others which I don't know much about. Otherwise, I found them on a recommended website of password managers that has a storage that you can control. Do your own research. Obviously, protect multi-factor sources. Lock your SIM in your phone, but remember the PIN. Use decent email security, but remember your email password and obviously guard your dongle. There's a couple of websites here, which is interesting. Have I been pawned? And Google has this dark web dashboard, and these guys and others provide a service to see if your digest of your password has been stolen somewhere. So particularly if you use the same password for multiple websites, one of those websites might have been hacked. Those list of digests might have gone on to a dark web server to be sold, and someone may have run, Jack the Ripper on those digests and figured out your passwords and will sell in those for a bounty somewhere. These websites are quite good. Just type in your email address and it'll come up with, has your password been guessed or not? Kind of useful service. And if it has, you need to run around and change your, the password that you've used on, 10 dozen websites. And finally, the list of references as usual. Draw your attention down to our forum where we've got a page already open, ready to discuss things. That's it. So I see, let's stop sharing. So we're back to normal screens. Oh, we've got some questions. Good, good. John.
It's just a comment, really. Thank you very much for that. It did actually register with me in various ways. Just feeling slightly virtuous. I saw the table at the beginning of your presentation, the one that shows length and how long it takes. Yep. I saw a version of that about, I don't know, 7 or 8 years ago. And it convinced me immediately to move to long passwords, a passphrase, which is virtually impossible, it seems to me. Once you've stuck a symbol and a number in there as well, I mean, you're off into trillions of years before anybody's going to be able to hack you. And it convinced me then, and I've run with that ever since.
It's a good point. Of course, computers are getting faster and faster to do these things, and tools like John the Ripper are starting to use GPUs to make it even faster. And so the time to guess passwords from the digest is just getting shorter and shorter.
Yeah, but if you're at 20 odd characters, you're still talking,
Yeah.
maybe only a billion years as opposed to a trillion. But
yeah, good point. Oh,
yeah, I just wonder what your thoughts were on the Apple keychain as a password manager, because it's kind of built into all their devices, which to a large extent you have to trust their software if you're using them.
Yes, yeah. I mean, I've got an Android phone, but I've got a MacBook, so I am exposed at least somewhat to the Apple ecosystem. And absolutely, it's a good way to manage passwords. If all your devices are Apple, mine isn't, but if all your devices are Apple, then it's obviously the go-to way to store your password is to use the keychain.
Yeah, they are now in my case, but it was a right pain when I was across multiple platforms. And at the end of the day, you end up taking a view on infrastructure and usability. The other comment I would make is that it wasn't that long ago, and it still happens, a lot of websites and particularly e-shopping insist that you use your email address as part of the login credential. And I think that's absolutely stupid because firstly, everybody knows it. And so they've only got to guess one thing, and that's your password. And then they know it's you. But secondly, if you think about it, if it was a separate thing you used to log in as your ID, that's two things for people to guess, and it stops people doing a denial of service attack against you. If I know your email, I can just try and get into your Amazon website or whatever 10 times, and after that I've locked you out and caused you a lot of grief. And people, kids, etc., will do that just for fun, and some people for other twisted reasons. I've never understood why they insist on doing that. It seems to me utterly dumb.
Yes, yeah, I mean, yeah, good points. Now, while you're there, Paul, I'm just flipping through the chat and I see that you've made multiple points in the chat. Is there anything in there you want to raise?
I think we've covered most of them.
Okay.
Apart from the FIDO, as I say, how you move it to other devices, which is not an easy thing to do, is it? Does each device generate its own FIDO credential that's associated with you?
Yeah, most people will use the sync feature in their browser. So
okay. Yeah.
a Chrome and Firefox, you can log into Google and that will sync your browser settings between all your devices, and Firefox is the same, and passkeys are synced via that mechanism. So that's the way most people will do it. What I'm personally doing is waiting for my password manager to support passkeys, and then I'll put everything in there.
Yeah. Okay. So that just leaves one other question then. How do we know when a website's offering passkeys? Because I think Apple went over to this a little while ago, but I don't think there's many sites that actually offer it. But how do you know when they're offering it or not?
And when you go to the login page, it will say so.
Oh, right. Okay. Thanks for that, Peter.
Just a comment, Peter, if I might, just on the
Yeah, John. Yeah.
If you use something like Gmail or one of the other major services, you can always have versions of your email address which are unique to a site. So if you put a plus dot in there, and you have a convention for yourself, say another 3 or 4 characters after that, that's an email. It doesn't cost you anything, but it doesn't affect how you operate on that email address, but it does make it unique to that particular site. Well, I think that's worth doing.
Yeah, good point. It's called plus addressing or sub addressing. It's as part of the internet standards. There's other ways to do that. Things like Firefox have got a mechanism when you register to a website. It says choose a random email address for this website. It'll generate a random email address, but any emails to that address gets forwarded to you. And Apple have got the same sort of technique. So yeah, it's a good point that you make. Thank you. John, you're next on my list.
Well, thanks. Is it very easy to install malicious software backdoors that can actually transmit your keystroke so you can find your password that way?
Yeah, we talked about that a little bit in the USB talk. So yes, if someone's got physical access to your keyboard, they can put a USB keylogger on and will log your passwords. Yes, that is a very, well, I'll say common, but it does happen, right? But obviously with passkeys, they're not going to log. There's no password to type in, so there's no keys to capture to replay.
Right,
So
thank you.
passkeys does get around that particular problem. Barry.
Hi, thanks. Thanks, Peter. Enjoyed the talk. A lot of it went way over my head as usual. I'm not particularly computer savvy. I've just got a question. This business about how these the passwords can be deduced by bad actors just through trial and error, brute force, just by number of. And the business about having more characters gives more strength. Most websites, if you try and log in several times with the wrong password, after a while they shut you out for a time. So how do these brute force machines get around that problem?
They usually rely on the digest being stolen from the website. So they don't guess the password by typing in passwords on the login prompt. As you say, you'll usually get locked out, or websites will have like a delay between each attempt to discourage that. So guessing the passwords really depends on someone hacking into the website and stealing the digests, and then guessing the passwords from the digest without touching the website.
Okay, so it's not
hard to do, you know. Yeah. But you know what I do is there is a website that lists the European Union fines for insecure sites, and that can be quite interesting. Very often, even big companies, they leak password digest online in some weird Amazon basket or something, and then they get fined for that. And then everyone gets an email saying, you know, please change your password. It's been breached. So even though, you know, passwords can be cracked fairly quickly, it's hard for the hacker to get to the first stage to actually get hold of your digest. Neil.
Thanks.
Hello, Neil.
Yeah, hold on.
There you go.
That is it. Yeah, yeah. Sorry, couldn't find it with anything. I was just going to ask you whether you, as you're keeping track of this, whether you've heard anything about any quantum computers that are now actually where they're using the quantum, the entanglement thing and actually getting it to work on, on another way of doing passwordless things.
I've not been tracking that one specifically, but we talked about private and public keys, and associated with those is the algorithm to do the encryption. You know, take the private key, run through some algorithm to produce the packet that should go over the network. And there is discussions to have these algorithms which are quantum secure. In other words, those algorithms are likely to be still secure in the post-quantum world, as they tend to talk about it.
Yeah. Okay. Interesting. Thanks. Yeah.
John, back again.
Just to come back on the digest thing, even if they steal the digest, even if they get access to the digest, I mean, if your password is 20 characters long, it's still going to take them more time than they care about. So presumably all of those people have systems that say, well, we've spent 5 minutes or 2 minutes or 3 minutes on this, let's move on to the next one, because, you know, so by having those long passwords, you're automatically making yourself secure against those sort of hackers.
Yes, that is true. However, I would say, now remember, I think tools like John the Ripper works with a huge list of passwords. You know, it starts with QWERTY, then secret, then let me in, and all these common passwords. And as soon as someone's used a passphrase like Mary has a little lamb, that will go into the list of passwords that's fed into John the Ripper. And then those, 5 trillion years suddenly becomes down to, a couple of hours. So, choosing these long phrases, it's not only about choosing these long phrases, it's also about choosing a rather unique long phrase. Paul.
Yeah, just a couple of points. Quite often, websites do password reset via sending you a link that you click in your email, which to me doesn't seem a very clever thing to do, because somebody intercepting that email and getting there before you gets control at that point. But I don't know what you can do about that. One of the things to be aware of for everybody is that there are cameras everywhere these days. They're in pubs, they're in cafes, they're in train stations, they're on trains, and they get recorded for crime purposes. But if anybody gets access to that video, be it the operators or somebody intersecting the link, they will see whatever you type in on your phone, and actually what's on your phone or your computer at the time if you're using it in a public place. So that is something to be very, very cognizant about these days. But also another hint, when using some of these websites, I use a thing called 10-minute email. And basically it throws it away, but I'm able to do certain things like create a login to something I'm never probably going to use much at all, and set it up anonymously so I'm not marketed, etc. And that email just gets thrown away at the end of the 10 minutes. The only final thing I would say is that it's never ever, I don't think, a good idea to use your main email that is your device email. In other words, if you're on Apple, to use the iCloud, you need an Apple email. If you're on Google, to use an Android, you need a Google email. I never use that for correspondence, nor do I disclose it to anybody, because if somebody hacks into that, they can get at your cloud information.
Yep. Just one follow-up comment, some good tips there. The current recommendation from NIST to reset your password is to use a completely separate path. So instead of using email, or as well as using the email reset link, websites should be using an additional technique, for example, an SMS message or a phone call or something like that. So more than one factor to verify you before they do a reset password. That's the current recommendation for websites.
I try and use the SMS option if they offer it.
Mm.
Although it does mean I've got to disclose a phone number to that particular outfit, which is another thing. And you might detect a common theme here. One of the things that's so damned annoying about using the web these days is everybody's collecting everything on you for marketing reasons. And you know, people like Google know far more about me than my doctor does, and the state does as well. You know, which I can't do a lot about except try and remain anonymous to Google.
Mm-hmm. Yep. Peter.
Hi. First of all, thank you very much indeed. Very, very illuminating. I don't get so het up about this, to be honest. I'm very careful with the key sites I go to, that's for sure. I think really it's easy to become a bit narcissistic in this process. As long as one takes reasonable precautions around your main financial assets, then you should be okay most of the time, I think. I just think this stuff operates at different levels. As an individual, you're pretty much small fry. But obviously, at a corporate level, and even worse than that, at a governmental level, this stuff gets really important because you can unlock so much at that level. That's all I'd say. I think really the only thing I thought about the passkey, how easy is it to have on multiple devices? I didn't quite grasp how easy it was to do that, Peter.
Yeah, so the multiple devices, what most people will do is just sync it via their browser. So,
Okay.
you know, Firefox has a synchronize option, as does Chrome and so on. So if you use Firefox on multiple devices, then passkeys will follow you. That's what most people do. Or you can use your Apple keychain to store it, or you can use your password manager to store it.
A lot of the time these days, they're doing these thin apps on your phone. They're not going through the browser so much. What does one do with these skinny apps which sit, you know, an app on your phone?
Yeah, password managers will work with that. I use the same password manager on my desktop on my phone, and the way it typically works is it acts as a keyboard.
Yes.
When you go to an app and it gets a username, then you click on the keyboard and it will type the username and password for you.
Okay, that's the way out of that one. Is okay, and that's the password manager will do that for you. You're saying,
yep.
Password manager. Okay, got it.
Yep.
Will you do a pass key as well, or not though?
The password manager I use doesn't support passkey quite yet, but will do soon. And these password managers, as well as using a keyboard to talk to your apps, will talk to your browser directly via a browser plugin. So which is easier to use, you know, for automatic logins via your password manager. But obviously it'll do the passkey directly between your password manager and your browser.
Okay. Thank you. Thank you. Thanks very much indeed. Very enjoyable. Thank you.
John.
I've noticed some people have a notification on their phone displays text messages even though the phone's locked, and depending on the length of the message that comes in from the bank or whatever, you can quite easily read a one-time passcode even though the phone's locked, and I don't think people look at that too much.
Very good point. Yep, that has actually come up before our sessions, but yes, a good point, very well made. You should go into your notification settings and turn that notification off. Oh, again.
Yeah, just on that app thing, I've got a trick that I know works for me using the keychain. Partly, and the same for a password manager. What I've found is a lot of the apps that you put on your phone don't have an email address or a website associated with them. So if you're trying to store that long password that can be generated on your phone, somewhere where you can get at it for later and copy it and paste or whatever, the way to do it is to set up a bogus website address that's got the app name in it. But it's .co.america. Oceanic. Whatever afterwards, where it's not going to go to a real website, but it allows you to get round this sort of restricted limitation on some of the password managers and store it. so that you can then go and look it up later if you need to in your keyword or password manager. And I found that was a great way around getting around this problem of where the heck did I put the password for that particular app? Because I have to sign in again because they've just refreshed it and I can't remember the flipping password for it.
Okay, thank you for that. I've not come across that one before, so that's a good one. Okay, I've got no more hands up. Is there anything else anyone wants to mention? So next month, generative AI, how it works, playing around with large language models. Hopefully you can make that one.
Good.
Let's close it then. Thank you very much for attending. See you
Fabulous.
next month.
Thanks, Peter.
Thank you,
Great.
Peter. Very good.
Thank you. Very
Enjoyed it.
interesting talk.
Excellent.
Thank you, Peter.
Glad you enjoyed it.
Very
Cheers. Bye-bye.
Really useful. Thank you, Peter.